All right, we're taking a look at gedit today, which was a request from a while ago. I've been a bit sick, so I figured gedit would be relatively simple and bounded. So this might be a somewhat short episode. So for those not familiar with it, gedit is a GNOME text editor. Very simple. This is it open up in the foreground. We'll look at a couple of files in the gedit interface itself, just so we are familiar with what the interface looks like. And then I believe, if I'm not mistaken, that gedit has been replaced or will be replaced in GNOME by, I forget what it's called, GNOME editor or something along those lines. But I think gedit is still a good starting place for taking a look at GTK applications. All right, so here's gedit app.h, and there's not a lot here. So we have this gbegin decals thing, which seems to be a GNOME or GTK macro or of some kind. And then we have the end decals here. And then we have the struct, which is just this everything in the code seems to be prefixed with gedit something or other. And we get this gedit app class. And we have essentially a reference to the parent class. And we have things like show help, get help URI, and for example, show help takes a reference to this app, or at least I assume it's supposed to be this app, the parent window, and then some stuff like the name of the user manual and a link to the manual. And then we have things like create window, get main windows, get documents, etc., and setting the window title. This is just the header file. Obviously, the implementations will have a bit more information. Let's see if we can open the implementation file. So if we're here, let's see. So open dialog, we have other documents. This will open up a file browser. This is all standard GTK stuff. And let's see if we can find gedit app.c. I don't see a gedit app.c. I see a gedit.c and some other stuff, but I have those open in other windows. All right, so that's what gedit looks like. We've got tabs. We have syntax highlighting. We have line numbers, things that you would expect from most editors. And we also have this information. This is, I guess, what kind of file it is. It's a C/Objective-C header. And then I can change it to awk. And that should change the syntax highlighting. If I just tell it C. And then we have some stuff like tab width, line and column number, and ints, which I'm going to guess is probably means we're in insert mode as opposed to like overwrite mode. And here's in the GitLab window now, here's gedit.c. Is this where I want to be? I think that there is yeah, okay, so here's main. So the other stuff in gedit.c is not so interesting. It's kind of just setting up some stuff for like Windows or whatever environment you're in. And main is going to be really simple. We declare some stuff, but the real work seems to be down here. We're going to call dirs init, which presumably initializes some directory stuff. We'll set up internationalization in Pango. Tepl init. Tepl is I think tepl is the thing that's doing real work as far as syntax highlighting goes. We'll take a look at that in a little bit. And then we are calling this factory function to get a new factory and setting this tepl singleton thing. Then we call g_object_new with the type being this, I guess we have this string thing, this like key that says that this looks like MIME stuff. The application ID is org gnome.gedit and some flags, and that gives us the app. And then we're going to run the application with argc and argv, and this seems to be an infinite loop because it's going to return a status. And if we get down to line 178, it looks like we're starting to clean up. So we're going to unref singleton of the settings. I guess there's a settings singleton so that there's only one. If you have multiple windows, they should all share the same settings object. Then we're going to dispose of the app. And there's this comment here about breaking reference cycles. I don't know what the P's extension set is, but there might be reference cycles, so we have to be concerned about that. We're doing this add weak pointer stuff. I'm not sure what that's for. and then we're unwrapping the app. These three all may be governed by the same comment. I'm not sure if this is all part of the same logic. And then we just check whether the app is null. We expect it to be null at this point, and if it's not null, we say that we're leaking some stuff, and we call tuple finalize, and we call dir's shutdown and returns tabs. And so that's really simple. That's a really simple loop. Maybe before we go too much further, we'll take a quick look at tuple, just so that we know what it is. I believe this is a separate library, so we're not going to dig into the tuple source code at this point. Not sure if this is the right one. No. See if I can convince Google that I really mean tuple. Not sure why I'm not finding it, but what I saw before was it's basically an extension of like GTK source view. Okay, so DuckDuckGo has it. So tuple is a library that eases the development of GTK source view based text editors and IDEs. So GTK source view, as its name implies, should be some GTK object for viewing source code, basically an extension of whatever like rich text or plain text GTK widget there is. This is some specialization for source, and then tuple is a library that makes working with them simpler. It's an acronym for Text Editor Product Line, previously called GTEF, and it follows a product line approach inspired by feature-oriented software product lines, concepts, and implementations. And the idea is to create several specialized text editors. For example, specialized for one programming language or one development platform or a small group of languages. So this is just provides you essentially with the ability to section off development into approachable chunks so that maybe the C++ features are sufficiently different from like the Java features that you're going to have different implementations. And so that's what tuple is, and that's why we initialize it. Okay, so that was main. Here's a gedit window, and this should mainly be, I'm expecting this to be mostly GTK stuff, but we'll see. I'm not sure what this private stuff, I've seen private a few times in the source code. I'm not sure what private means. Maybe it just means private in the, as in like local to the unit of development. But we have things like pointers to editor settings, UI settings, Windows settings, lots of setting stuff. Multi-notebook. I don't know what a gedit notebook is, but I imagine it's some grouping of files. H and V in HPane and VPane, I'm going to guess are horizontal and vertical. We have a message bus and the P's extension set that was possibly causing loops, cycles, and in reference counting. And then some widgets, things like event boxes. I don't know what revealer, full screen revealer. Something about, I guess, toggling full screen and things like status bars, headers, standard UI stuff, which I'm mostly going to gloss over. And then we have these enums. These look like signals given their name. Like if tab added, presumably something's going to emit a tab added signal. How is it going to emit it? I'm not sure, but presumably in the message bus, which we saw somewhere. I'm not sure where the message bus is, but it's somewhere. We'll look at the file and tab reordered, all of this sort of stuff. Like somebody's monkeying about with tabs. Like if I do this, whoops, and switch one tab to another, that should presumably cause some sort of message to be emitted on the message bus. And get property. So I guess this is like a getter for some sort of property. So we've got this generic object that I suppose you can pass in. You're going to give it a property ID, which appears to be a GTK specialized unsigned int. And I'm going to guess, since this is void, we're going to get the G value and maybe the parameter spec as outputs. Then we have some stuff like setting state and whatnot. And window events. Maybe let's take a look at one of these events. Window configure event is going to return a Boolean. and it's going to take pointers to the widget in the event. The event may be an out parameter. We'll see. We're going to call gedit window on the widget. I'm not sure exactly what that does, but that's going to give us, that's going to take us from a GTK widget to a gedit window. I'm not sure if that can fail. If it fails, I'm not sure what happens. And if GTK widget get realized of the widget, I'm not sure what realized is, maybe whether it's being like used or whether it's inflated or what have you. And then we're going to check the window state and some stuff about whether it's maximized in full screen, in which case we will save the window state on the widget. And regardless of how this if turns out, we're going to return GTK widget class of parent class configure event on widget and event. I'm not sure really what that does because I haven't looked at those functions, but presumably it does something relatively straightforward. Okay, so that's windowy stuff. Here's the Windows header. I guess now we don't really need to look at this, although we get some enums, like is the window state normal? I don't know what normal means, but I guess not doing other things, whether it's saving, whether you're printing or loading, whether there's an error. And these are just like the signatures of the functions. Returns a newly allocated list with all the documents that need to be saved before closing the window. So this essentially, these are the dirty documents that need to be saved, and you can imagine that you would use that as part of the closing logic to make sure that everything gets saved. Okay, so now that I've looked at those ones over there, I will take a look at earlier in the stack where I opened other files. So here's gedit app.h. This is presumably going to be one of the main headers. And I remember this is small. Yeah, so this is like 83 lines. And we've got this gbegin-dickles thing again. And we've got this app class. Is this the one that I looked at in... yeah, this is the one I already looked at in gedit. Okay, so we saw that. Here's gedit app.c. We get another struct, which has a plugins engine, a CSS provider. So I guess it's using CSS for themes, which makes sense. Some stuff about page edit and print setup. These are GTK. So this presumably is all relatively standard for all GTK apps. I'm just curious, like, what is it importing GTK wise? I'm not sure. We've got TEPL. We've got a bunch of gedit stuff, but I don't see anything that looks just GTK-ish. All right, that's fine. And then we've got menu stuff and something about command line parsing. New window, which is a Boolean, new document. Encoding, presumably what kind of language it's encoded in, like not language, but like whether it's UTF-8 or ASCII or whatever. Some reference to the standard in stream, a list of files, line position, column position, etc. And a lot of these are, I guess all of them are like GTK-ified versions of standard C types. And then we've got option entries. I'm not sure what option entries is, but we have things like versions, listing available encodings, and so on. I guess that looks like command line stuff, potentially. And then we've got something like we're going to dispose of the app, which you're going to call on some object. And you're going to get the app instance from the object, calling gedit app on it and clearing a bunch of stuff. And then ultimately, presumably returning, ultimately calling dispose. And then this is like how to get help information. For example, on the show help implementation, we call GTK show URI on window on the current window, and then let's see what happens if I do that. So if I call help, will it show a URI? I'm not sure that this looks like it's opening a new window, and maybe it is doing that. Show URI on window. Do you get this function? I don't know if we get an implementation. Let's see if there's a GTK reference for what this does. This is a convenience function for launching the default application to show the URI. For launching the default application. Okay, so it is supposed to launch something, it looks like. And this is just some GTK function. Okay. Gedit document, I'm going to guess document is the basic file thing. Like maybe this is a document. We'll see. And we've got this document class, which has the tuple, a tuple buffer class as its parent. And we're going to do things like loaded. Oh, these are signals. I'm not sure what the difference is going to be between load and loaded and saved. I guess maybe load is the intention to load and loaded is the loading finished. Save is possibly the intention to save, whereas saved is maybe the signal that saving has finished. And we have functions like create a new document, a get file, which you're going to take in a document and return a source file. I'm not sure if that means that the document has an underlying file. Where's the class? I'm not sure. We can look at the implementation of what the get file is actually doing. But we could also get things like content type, MIME type, language, all of the things you associate with needing to do editing. So here's the C file next. Let's see if, okay, we get a struct, which does have an underlying source file, which I'm going to guess is what gedit is ultimately doing. It's just looking at this struct and returning the pointer to the file. But the what's the name here? The gedit document private. So this is a private struct, and the private struct has the source file, the tuple metadata, content type, when did you last save it, a search context for incremental search, and this seems to be a GTK source thing. So whatever the GTK source people are doing, they have some sort of search implementation. And the language set by user, which is an int. I'm not sure how that works. Maybe some sort of enum. Maybe it's just being treated as a Boolean about whether the user has set a language that's different from the system. And whether the search, I guess, whether the search is empty. The search is empty if there's no search context, or if the search text is empty. It is used for the sensitivity of some menu actions. Okay, so there are some menu actions that I guess change their behavior depending on whether somebody's actively searching or not. And create says it will create a file if location points to a non-existing file. All right, these ones seem to be like Booleans set to true. So I'm guessing create can be 1 or 0. And if it's set to 0, we don't create the new file. And if it's set to 1, we do create a new file. Then we have some enums, like what is the content? I guess these are like properties. So we have content type, MIME type, empty search, and presumably there's some switch statement that's going to look at these properties and do various different things. And these are the signals load, loaded, saved that we saw before. And we have a parameter spec, which is basically a list of properties, it looks like. And we have things like load metadata manager, where we get instance from the doc. And this is the private version of the doc. And we call get location on the private thing, and we check that it's not null. Really simple implementations for all of this stuff so far. Similarly for save metadata. I'm not sure where we're saving it, presumably some GTK place. Let's see. Can we see that? We're going to get the instance. We're going to check whether so language set by user is treated like a Boolean, even though it seems to be implemented as an int. We're going to get the position of what? GTK text iter get offset. Maybe position of the cursor into the document, possibly. Dump printf. I'm not sure. Then we're checking the language. And we're going to call set metadata. See if we can find this implementation. this doesn't look like the implementation yet. Maybe here. That's metadata on a document. But where does it save it? Okay, it just sets it in the struct, I guess. Whatever VA start is, I'm not sure what it is, but we're going to do some key stuff. We're going to call tuple metadata set. And it will save metadata to metadata manager. And I guess metadata manager might have multiple implementations. GTK source file get location. If location is not null, then we do some stuff. So where's location? So location is here. Yeah, it seems like we're going to essentially save it to a file maybe that we get from here. Or we save it with the source file. I'm not sure. Okay. So let me real quick check that, yeah. I just wanted to make sure this is gedit/gedit because I think this convention might differ from what GitHub uses. All right, so here's gedit factory. We saw this called essentially in the main method. And it's essentially just a wrapper around the tuple, whatever the tuple is using for a factory. And the abstract factory class. Here's the implementation. So factory create file. Factory init does nothing. Factory new is going to return a g-object new, gedit type factory null. Gedit factory class init is going to take the class, call this tuple abstract factory class thing on it, and then we're going to set the factory class's create file method to the function gedit factory create file. And similarly for the metadata manager. And gedit factory create file is going to create this tuple file variable, call tuple file new, and set it to the file, and then set untitled file callback. Set some sort of callback, I guess, because it's untitled because it doesn't have a title yet. They're going to return the file. What is this callback? It's just going to call g stirred up untitled document with this untitled document printf looking thing, and then some untitled file number. Cool. Here's an implementation of a file chooser. Presumably this is just calling out the GTK. I don't see why they would really customize this too much. But we've got a G object as a parent and a file chooser private priv thing. And what? Some stuff, internal stuff. File chooser is native. I guess you might have the native, like maybe if you're on KDE, you use the KDE file chooser if native is true. I don't know. Actually, this is relative. We've got a lot of stuff, more stuff than I thought. But I guess chooser show, get current folder, kind of all stuff you would expect. Do I have the C file open? Yeah, I do. Okay. So here's the file chooser thing. I'm not going to look too closely at this because this is not so specific to gedit. And the idea here is to look at something pretty simple. But you can see we've got things like get supported globs, list generated with tuples, share mime info list, text plain globs tool. These are seem to be all of the file extensions that are supported, like GV, GVP. I don't know what some of these are. KDE link, no idea. Man is maybe man pages. Manifest could be almost anything that has a manifest, I guess. Perl, and just sort of all sorts of well-known file stuff. Scala. Okay, so that's file chooser stuff. Here's message bus, which I was a little bit surprised to see them implement their own message bus. I'm not sure if there's a GTK message bus that they're wrapping, but we'll see. So we've got a bunch of defines, including set gedit type message bus, and is being set to this function gedit message bus type get type, whatever that is. Maybe we'll run into it. The message bus struct just has a parent and this private object. This is the pattern we've seen throughout, that there's essentially a private implementation that is that's somehow hidden, and then the public object, I guess, has the ability to get the private implementation. And the message bus class has a parent class. I'm not sure what you're going to use for the parent class, but we have the ability to dispatch a message, which will take a reference to the bus, and the message, I guess, to dispatch. And registered, which is maybe like subscribe, which will take a message bus and an object path and a method. Maybe this is listening for specific methods. I'm guessing. I'm not sure what object path is doing, whether that's well, I guess we'll see how it's used. And then unregistered, which is presumably a little bit like unsubscribe. And they've got a callback. And I guess this is a method. And it's going to take a bus, a message, and a pointer to user data. And I guess we have a for each, which will presumably do mapping over a bunch of messages. We're going to we have an object path and a list of object paths, a list of messages, and some pointer to user data. And we can do things like look up stuff on the message bus. We can register, unregister all. Check whether we're registered by calling is registered, call for each. And connect, bus connect. I don't know how that's different from register. Bus disconnect, block by function. This is relatively involved. Unblock by function. Send message sync, maybe synchronously. Gedit bus send and bus send sync. Let's look at the C file. We get comments in this. I guess their style is that they're doing comments in the C file instead of the header. The gedit message callback is a callback signature used for connecting callback functions to be called when a message is received. Okay, so this is for, you want to know when tabs change, and when tabs change, you want to execute different callbacks. And I guess you use that with gedit message callback. And you're going to set which bus the message is sent on, the message that was sent, and the supplied user data when connecting the callback. I'm not sure what that is. Maybe that's the stuff passed into the callback. And here we get the description of what the message bus actually is. Personally, I would have put this in the header, but they have their own style. So we see gedit has a communication bus very similar to dbus. Yeah, this was my question. Why not just use dbus? Its primary use is to allow easy communication between plugins. Okay, so this message passing is for plugins to talk to each other, but it can also be used to expose gedit functionality to external applications by providing dbus bindings for the internal gedit message bus. Okay, so you can use it, I guess, you can extend it to talk to dbus, or maybe they've already extended it, I'm not sure. There are two different communication buses available. The default bus is an application-wide communication bus. In addition, each gedit window has a separate private bus. This makes it easier for plugins to communicate to other plugins in the same window. So if I have like 6 plugins set up for, let's say, C headers, then I guess they can all communicate here, but I might also need to blast a message to all of the windows at once. Now, I'm not sure why you couldn't just blast all of the messages and have each window know to look for, if you could implement local messages, I guess, using the app-wide message bus, just by having Windows subscribe to events that are from their own window. But I guess there's a reason that they have for having 2 different message buses. Concept of the message bus is very simple. You can register a message type on the bus, specified as a method at a specified object path with a certain set of method arguments. You can then connect callback functions for this message type on the bus. Whenever a message with the object path and method for which callbacks are connected over the bus is sent over the bus, the callbacks are called. There's no distinction between methods and signals. Signals are simply messages where sender and receiver have switched roles. Okay. And we get more implementation stuff. So I'm not going to dig into this further. This is maybe the most complicated part of gedit so far. I'm not sure that, just from a simplicity point of view, it seems like you could delegate this complexity elsewhere. I'm not sure how rich the gedit plugin system is, or how well used this was or is. I'm not sure how active gedit development is, but this is a little bit surprising to me, the complexity of the message bus. On the other hand, it seems to mostly fit into 2 files, so it's not hugely complex. Here's gedit message, which should just be the message implementation. And we get, again, a little bit more complexity, but I'm going to mostly ignore it. More messagey stuff. I still don't really know what object path is, but I'm going to guess it's, I'm not sure. Let's look at is valid object path. If not object path, return false. If object path is not equal to slash, return false. While object path, if object path is slash, I guess it's the paths are separated by slashes. I'm not sure if this is like literal file systems. But we're going to increment the object path counter of some kind, and check that, again, this looks like parsing stuff. Is it alphanumeric? Or rather, is it alpha? Is it an underscore? In which case, we return false, etc. See if we can find a reference for gedit object path. Okay, so here's this seems to be an example: slash plugin slash example, and then some method as a string. Evoke slash plugin slash example dot method, and I'm guessing this is really a file in some folder called plugins, and the plugin is called example, and maybe dot method is a method on that plugin. Here's an implementation of tabs. And this should just basically be tabs. So we're going to have some, so these are 2 tabs. Each one is going to have, I guess, 1 document. They can move around, so they need to know maybe what their position is. And maybe you can map over tabs in some way to execute the same thing for all tabs. And so let's see if that's close to being accurate. We've got this Gnome that has some tab state, like whether you're loading, reverting, printing, error conditions, closing, etc. You can load a file into a tab. You can, I guess, load a stream into a tab. Get the underlying view. You can get the underlying document and state, etc. And that's all relatively straightforward. And here's the struct. We've got a parent. The tabs have a parent instance. Whatever a GTK box is, maybe a GTK box is the thing that's enclosing the tabs. And we've got tab state, editor settings, which should be ultimately, I guess, a reference to a singleton. A view frame, which should just be the view frame, an info bar. Let's see if you can see the info bar. Is this the info bar? I'm not sure. At the bottom. Some stuff about printing. I'm a little bit surprised that printing stuff is showing up so frequently here, but it's not that surprising. Print preview. I guess save flags, probably whether it's been saved and maybe last time it's been saved, or possibly what to do when it's saved. Things like scroll timeout, scroll idle, how frequently to autosave, a cancelable. I'm not sure what cancelable is doing. Whether maybe editable is maybe whether the tab is editable. Autosave is presumably whether to autosave, and whether to ask if it's externally modified. So maybe whether the file is externally modified. I don't know how you could externally modify the tab itself. And we've got things like saver data, which has a file saver and a timer. Notes about create backup saver flag. At the beginning of a new file saving, force no backup is false. Okay, so this is about autosave and that sort of thing. And they've got stuff like loader data, which also has a timer and line and column position, and has some GTK source file loader. And some enum properties, things like the state, autosave, etc. And I'll skip the rest. I have no idea what a view activatable is, but I've noticed that comments are in the C file, so maybe this will tell us. Gedit view activatable. Interface for activatable extensions on views. See also P's extension set. gedit view activatable is an interface which should be implemented by extensions that should be activated on a gedit view. So presumably this is kind of like things like in Emacs, this would be handled by, when you open maybe like a Haskell file, or then you should do, maybe connect the LSP server or something if you have that sort of plugin. I'm going to guess. Gedit view activatable default init. It's going to take some activatable interface. We're going to install a property on the interface. And then we've got this activate function. Yeah, I don't know. But let's look up this P's thing since it's come up many times. P's extension set. P's dot extension set. A proxy for a set of extensions of the same type. A P's extension set is an object which provides method calls to a set of actual extensions. It's an object which proxies method calls to a set of actual extension. This is maybe like a what's the word? Like node. Like a reverse proxy. You're going to talk to the extension set, and the extension set's going to fan out the messages to the actual extensions. P's extension set will automatically track loading and unloading of the plugins and signal appearance and disappearance of new extension instances. You should connect to those signals if you wish to call specific methods on loading or unloading time. Okay, so some extension stuff. This is appears to be not gedit specific, but instead something that's GTK wide, or can be available to GTK apps if they choose to. And view activatable seems to be saying that activatable extensions on views, that you're going to figure out which extensions to activate based on the view. And here's a gedit view, which I don't think we've looked at. We've got a tuple view, which is presumably doing most of the actual work. And then we've got this private thing. Drop URIs. I'm not sure what drop URIs is. We've got padding and a parent class. That's really it. You've got URI list. And that's it. We gotta, maybe the implementation is more interesting. The gedit view private, we have this set of extensions, which is a P's extension set. Direct save URI. Something about saving. I'm not sure if the URI is supposed to be like a file, or if it's something that can go on the internet, maybe over SSH. Tuple signal group. File signal group. I'm not sure what a file signal group is, but maybe these are sets of files that are grouped together, and so should maybe emit signals if one of them changes. Like perhaps if you need to like recompile or whatever, because the files are all like importing each other. And this target URI list and xdnd direct save. And signal drop URIs and signals. Here's update editable, which will take a gedit view and we are going to take the view, presumably do something that's essentially casting it as a GTK text view. And then we're going to get the underlying buffer, I suppose, and cast that as a gedit document. Then we're going to get the file from the document, and then we're going to set it as editable by taking the view, turning it into a GTK text view, and then setting it to, I guess, the reverse of the opposite of source file is read-only on the file. Is that right? I guess if it's read-only, then it's not editable. So this is just, yeah, I guess editable is essentially the opposite of read-only. And file read-only notify callback. This is some sort of callback. It's just going to call update editable. Is that the function we just looked at? Yeah. Okay. And then we have, I guess, these look like signals essentially. Buffer changed. Either this is a signal or it's the function that's supposed to be called when the buffer changes. So let's assume it's supposed to be called when the buffer changes. Then we're going to get the doc and the file again. We've seen this a bunch of times. We're going to call group clear on the file signal group. And then we're going to create a new signal group from the file and set the view priv file signal group to there. And then we're going to call tepl signal group add on this new signal group. And we're going to call this gsignal connect thing, I guess, to connect the signal on the file, which was ultimately created from the view. And we're going to notify that it's read-only. And we're going to set this callback to the file read-only notify CB. And I guess whatever view is doing, I guess you need to pass in view as well. And then we're going to call update editable. All right, so this seems to be setting up the signal. I'm not sure why buffer changed means that we need to emit the read-only callback, read-only notify callback, but I guess that's a thing. Similarly for buffer changed and buffer notify callback, gedit view init, I guess this will initialize the view. We've got some target list, this debug stuff. We're going to get the view private instance from the view and set it to view arrow private. Drag and drop support. That's the direct save URI to null. And then we call GTK drag dest get target list GTK widget on the view and set the target list to that. Why? I'm not sure. We check that the target list is not null, in which case we add this stuff, whatever this stuff is all doing. Target X DNG direct save. I'm not sure really what drag and drop has to do with saving. Maybe this is like, yeah, I'm not sure. I don't even want to speculate. And then we've got more URI targets here. I'm mildly curious about what these URI targets are doing, but the rest of it I think is relatively straightforward, like more stuff for like if the fonts change. This is presumably something that tells you whether that the view has been constructed, or maybe it's called when the view is done being constructed, but we're going to set a bunch of stuff. For example, we're going to connect the signal that the font has changed, or at least set a callback for when the font changes. Similarly for show line numbers, auto indent. Then we get this drag get URI target. And I'm not sure. Drag motion. So let's look at gedit view URI drag and drop. This appears to be a hierarchy of the gedit view. These must be dependencies because everything seems to depend ultimately on glib.object. But gedit view is a source view and a scrollable. Source view is a text view under the hood, like an extended version of text view. Text view is an extended version of container, which is essentially an extended widget, which is this initially unowned. I guess that means that You can reparent it or change its owner. And then that's ultimately an object. And whatever ATK is, the ATK implementer interface is implemented by objects for which ATK object peers may be obtained. And it's buildable. Allows objects to extend and customize their deserialization from GTK Builder UI scripts. That's great, but what are the URIs? Drop URIs. The drop URI signal allows plugins to intercept the default drag and drop behavior for text/URI list. Okay, so this is for plugins to change what happens when you drag and drop. Using text URI list, I guess you're essentially passing a list mainly of files. Let's see if we can find anything else about it. Maybe view plugin URI. I'm not sure. I think it's something along those lines. Let's try one more time. Gedit drop, what was it? Drop URI or drop URIs? If this is a URL, emit signal drop URIs, otherwise chain up the signal. Drag data received. If you get drag data received with a widget and a context in X and Y, presumably this is like X and Y on the screen. Selection data, I guess, is probably what is selected, and some information and a timestamp. We're going to switch on the info. And if it's a target URI list, we take a look at the, we call utils drop get URIs from the selection data. If this list is null, then we emit a signal of drop URIs with 0 in the URI list and break. Sorry, if the URI list is non-null. I guess, yeah, whatever. So drop URIs is about drop presumably from drag and drop as opposed to like removing URIs. Just for fun, let's ask ChatGPT about, tell me about drop URIs in gedit. A specific feature or configuration. Oh, so it claims it doesn't know. Has been introduced after my last update. Okay, I guess ChatGPT doesn't know either. And let me ask Bard. Is a plugin for the gedit text editor that allows you to easily drop URLs from the web browser onto the editor and have them automatically converted to clickable links. It can be useful for quickly creating links to web pages in your documents. Is that really it? All right, let's try it. How about Microsoft.com? Let's send this to workspace 1, I guess. If I take this URI and I drag it, oop, that doesn't seem to do anything. What if I drag it to a line that doesn't have a comment in front of it? Doesn't seem to do anything especially interesting. Try one more time on an empty file. I don't know. Can what if I open a file in GitHub? Can I drag a source file into it, essentially? No? All right. I'm not sure what drop URIs is. Something related to URIs and plugins. And that's mostly it. We've seen about, so like I imagined, a lot of it's really simple. There's not a whole lot of complexity. A lot of the complexity about editing source files. Oh, sorry for the glare here. A lot of the stuff about editing source files is going to be handled by GTK source view. and by tuple. And everything else is essentially setting up windowing behavior. They've implemented a fairly complex message bus, and that's all in service of having a plugin system. And then whether all of that plugin system stuff pays off is really going to depend on how rich the ecosystem is of gedit plugins. And I have no idea how rich it is, but it seems like since gedit has been largely replaced by whatever the successor is called, I'm going to guess it was not the hugest. We have some default ones like quick open, snippets, external tools, change case, and so on and so forth. So that's gedit. That's a relatively simple GTK app. I hope you enjoyed it.